Hi, in this video I'm going to show you an example on how to find the domain and range of functions. In this specific example, I'll be using f of x equals x squared minus 4. Again, to find the domain of a function, domain is basically the set of numbers that can be used in the function. So, as you can see, our function is x squared minus 4. It says, given an x, I square the x, or I square the number, and then subtract by 4. By looking at the equation, or the function, you can easily tell that any number that you place on x can be squared. Okay, so any x that you place here can always be squared. So that number squared is still a number. And then when you subtract the number by 4, then that's still a number. So since any x can be placed, or any number can be placed on the x, it means my domain is a set of real numbers. And I can write that as, so x such that x is any real number. Okay, I can put any number on the x and it will give me a value for the function. Okay, now how do we find the range? Sometimes the range is not too obvious. Unlike the domain, you just analyze and check if any number will work on the function. Now for the case of the range, my common method would be to identify the graph of the function. In most cases, the given function is coming from a basic function. When I say a basic function, if f of x is equal to x squared minus 4, the basic form or the basic function where this came from is f of x equals x squared. Now it is so basic that almost like most people know the graph of x squared. And just to give you a quick review, the graph of x squared has a vertex at 0, 0, and the graph opens upward. If you want to be more specific with the points on the graph, you can just identify two more points. Say if x is 1 and negative 1, if I place 1 on the x, it's 1 squared, so the y value is at 1. So this is 1, 1. In the same way, if I put negative 1 on the x, if I square negative 1, the value of that would be positive 1. So if I will use the 3 points, including the vertex, and make a parabola, then I can have an estimate, or like a quick estimate of the graph. So this is the graph of x squared. Now from x squared, as we can see, the y value of the function or the graph starts at 0 and it's all the way up. So that means the y here are always greater than or equal to 0. Okay, so the range, if the question is what is the range of the function f of x equals x squared, then the answer should be y is greater than or equal to 0. Now however, the given problem is f of x equals x squared minus 4. So how is x squared minus 4 related to x squared? If you understand the movement of the functions relating to the basic functions, x squared minus 4, the minus 4 actually makes the graph of x squared go down by 4 units. Okay, so the x squared minus 4 will have a vertex at 0, negative 4, and the orientation is still going up. So if I want to identify the range of the function, as we can see in the graph, it's all the y value that are greater than or equal to negative 4. And there are no values below negative 4. So the range would be y. Y should be a real number, but y should be greater than or equal to negative 4. Okay, so this is a specific approach on how to find the range of a function. For domain, we did not encounter much problem because all we have to do is to analyze a function. Can I place any number on x so that I can get a value for the function? And the answer was yes. So the domain of the function is all real numbers. For the case of the range, it's not easy to check whether you can get all the numbers. So what we did is we analyze where the function is coming from. So x squared minus 4 can come from, or is based from the function x squared, or f of x equals x squared. And the minus 4 from the x squared minus 4 only makes the function x squared go down by negative 4. So by understanding that, I was able to graph f of x equals x squared minus 4, and from the graph, I was able to find the range of the function. Okay, so it's easier in a way because you have the visuals that will help you identify the range. Okay, now to support the domain, as you can see, the graph is going all the way up, but at the same time it's going to the left on this side. And on the other hand, the graph is moving up, but it's moving to the right infinitely. So it will cover both sides, going to negative infinity, and on the other side also, positive infinity. So it will cover all the real numbers. Therefore, the range or the domain of the function is all real numbers. The graph supported our analysis a while ago. Okay? Now the function can change. I can have a function f of x equals the square root of x minus 4. This is a function that is based on the function square root of x. So if I know the graph of square root of x and relate the square root of x minus 4 to the square root of x, then I'll be able to find the domain and range of the function. But that will have another discussion, okay? If the example is f of x equals the square root of x minus 4. But I hope you understand the concept of domain and range by simply looking at the specific function x squared minus 4. Okay? So I'll be showing more examples next time. So for now, I hope you have already understand the fundamental ideas behind domain and range. Okay? That's it.